Welcome to the Advances in Research and Innovation stream of SNOMED CT Expo 2023. My name is Victor Medina, and I am a surgical terminologist at SNOMED International. I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A button to type your questions to the presenter. On-site attendees, please use the microphone provided in the room. I'm now pleased to introduce Jørn Andre Jørgensen from Sorano.net, who will be presenting statistical analysis with R of a large data set of SNOMED CT encoded dentistry data using a survival analysis model. Jørn, please go ahead.
Thank you very much, and thank you for giving me the opportunity to present at this great expo. I will look at how we have used SNOMED encoded data from a Norwegian EHR and putting them into R and doing statistical analysis. During this presentation, I will look at what actually are our data, what data are we basing this on. We will look at the way we moved from graphics to SNOMED CT, both pre and post coordinations. Show you a little bit of how we started with analytics based on pre-coordinations, moving on to analytics based on post coordinations, where we also have this survival analysis, and then some final conclusions. The data we are basing this on is a patient cohort of 330,000 patients. The data extends from 1993, that's about 30 years. But due to some changes in the EHR around 2005, we have not based the further analytics on data before 2005. So what we are showing you today is approximately 310,000 patients. We have 29 million events. And that represents about 99.6% of the total amount of data. So that doesn't mean we have a detailed SNOMED classification for all the data, but we are in control of what the data are. So if we encountered like a administrative procedure, we simply said it's an administrative procedure because that's not what we're going to look at. But for the clinical data, we have a very good both granularity and coverage for most of the data. So we have events from actually 1st of January 2006, meaning after the 31st. So just starting off, this was a great moment. This is our first longitudinal graph of Snowlithical. So after pushing all of these data into an Elasticsearch database, we put Snowlithical on top, and this is the first graph we ever showed. And here you can see the very steep line, and that's when the new EHR was introduced. So before that, there is a lot of converted data, but it really doesn't give us anything. This graph shows prevalence of caries in this population, number of patients who have experienced caries during a year. So from 2006, you will see that the graph is fairly stable, and that represents where data is both granular and possible to encode. So what did we do? The thing is to capture a concept. All the terminologists sitting here think a lot about saying the concept is represented by an FSN, by a preferred term, which should be close to the clinician. We went about and said, well, our concept is actually graphically represented in our EHR. So we still get the idea, but we haven't used the text. But the importance of the concept is that it's the precise understanding a clinician has when observing the event. So the goal is to capture what is closest to the clinician's idea at the time. It should state their knowledge as accurately as possible. It should not be forced to state something they don't know, of course, but it should neither force them to exclude vital information they have. And that's where post-coordinations really come into play. So a terminology must be rich and known equal clinically relevant. This is, in Norway, our little gold mine. Small country, few vendors, meaning one single vendor actually has about 96, 97% of the population's dental data. So we're just one small county, but the system we have built could actually extend to represent most of the Norwegian population. And this is the graphical interface. So what we did was to say, well, given the idea of this sad tooth with a caries on top of it, that could be represented by this graphical structure. The graphical structure is underpinned by a database table. So what we did, we said, oh, I need to say, this is only an example. I was not allowed to show the database internal structure, of course. So what we basically did, we went in and identified what columns represents the actual meaning given by the clinician looking at the graphics. And we encoded it, and this is just a dummy, saying that if this and that and blah, 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 then we have the concept, which means dentin caries on the incisal ridge of the lower right canine tooth. This we can represent with saying it's primary active dental caries extending into the outer third dentin, or SNOMED concept. And then we put on both the anatomy for the tooth and the anatomy for the region of the tooth, given the post-coordination. At this point, I want to make it very clear that this is, of course, using highly structured dental data. But there is no reason why this couldn't be applied also to the rest of medicine. Because we wondered if we wanted it on t-shirt, but the computer doesn't care if it's a tooth or an arm. The computer treats concepts. And, oh, I said, I did need the red button. It just moved along. Okay, so we push this to Snowstorm X and we get a code back. So the code element down here represents the clinical idea. Now we have code we can store in our system and which we can query. Moving on. This is also by pre-coordinations. Now we have 3 graphs. The top one is all kinds of caries. The bottom one is caries into the outer third dentin, the sad tooth I just showed you. The middle blue one is the number of fillings. So does this give us any value? You can see the dip in all graphs. We were, of course, curious, why is there a dip? It's quite significant. So we said, is it caries? Has people suddenly stopped getting holes in their teeth? Is there anything here? No, it turns out we didn't examine as many. We actually did quite good on exams because we found those who had caries because caries dips less than examinations. And this is, of course, the COVID pandemic with the close down. The interesting part, of course, being that it started dipping before the COVID. So either people were psychics or this is reorganizing our organization, pulling a lot of the clinicians out of the clinic to sit in meetings. But still, investigations go down, caries goes down. It makes sense. And you can see the numbers on the far left here. These are 80,000 patients examined each year. So the numbers are so great that statistics are really powerful. We did some simple correlations also in Statistical. This is also based on pre-coordinations. We just said, if you ever had a filling, what is the likelihood that you get a pulpal diagnosis? Toothache. Well, it's about 16.5%. What's the odds if you have a filling that you will get another filling? Well, it's quite high. I think it's 85%. I can't see from my screen. If you never had a filling, it drops. So it's only 2.7% odds of getting a toothache. And it's down to 25% of getting another filling. So the thing is, don't get a filling and you'll never get a hole in your tooth. So here comes the interesting part. This is our first plot. This, I don't know if this has any clinical relevance, but it has a lot of technological relevance. We tried to see, can we use both subsumptions and attribute value pair search into a post-coordinated database and find instances? So we created a query against our data and said, give me all patients with a caries diagnosis or a treatment which is in SNOMED stated to be due to caries and sorted by their year of birth. And this is the graph. So who would want to know that query? I don't know. But it was cool just to see that we could throw this complex instruction on Snowstorm X and it sorted all of our post coordinations and we could then count the patients. This is based on 32,000 post coordinations, which we have fired one by one by one to Snowstorm X, classifying it. It took 7 hours. Maybe we could do a batch if we had a stronger computer. I don't know. It doesn't really matter. It took 7 hours one time, so it's really no big deal. Sadly, after I made this presentation, I have also seen when did we get new post coordinations. And it turns out that when you start working with it, you get a lot. Then you get few per year. Then you get a new version of the software and it spikes again because there's new functionality and it drops. So meaning you don't need to have these 7 hours every day. You need to have them once. And so it's no problem. And these queries look about like this. So now I wanted to say, give me all disorders of a tooth minus caries because it's so common. I want to see what else people are doing. I neither want the pulpal diagnosis and not periodontal disease. I want to see what else is happening here. Given this, we could throw this at Snowstorm. It gives us 1,225 post coordinations that should be included in my search. So R or the SQL database or the Oracle, whatever you're using, only treats the code as a string. And you use Snowstorm for filtering and for setting up your queries. And it really gives you more of this. If you want to know more about the techniques behind it, Ulrik Andersen here had a presentation yesterday, which shows you more about the technical foundation of it. So here's the result. So now I asked for the front teeth, the incisors, and the first molar, the one you get when you're 6. What happens on those teeth that are not caries and things? Well, a lot of them has mineralization disorders. Those are the congenital white spots placed on your teeth. You have a lot of fractures. You have some supernumerary teeth. You have some dental trauma. Probably the fractures and dental trauma are both reported on the same patient because you have trauma and then it's fractures. We can dig deeper in. The point here isn't, this isn't necessarily dentally relevant because we have to wash down the data very, very thoroughly before we make the dental conclusions. But as a method, it shows the power of both the post coordinations and SNOMED doing these kind of analytics. So now here you see it's both incisors and first molar. Here we have used SNOMED. So SNOMED, we just said, give us all of these teeth and all of that, those teeth and blah, 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 and mix it together. It handled it fine. In our data, it's the precise teeth, it's the precise diagnosis. And we could split the teeth and say, are there any difference between them? And yes, there are. Especially the dental trauma. It's not very surprising. But you tend to hit your front teeth, not your molars. And it makes sense. It's a children's population. But we also see, I think it's the green-blue part here, which are the hypomineralization or the mineralization disorders, where you see they're fairly equal. Then we could dig deeper and say, okay, these are the instances of teeth, not patients. How many patients are in this cohort? Well, that was 12,305. And then I can see how many has a demineralization of both teeth. Well, that was only 6,000. And this is interesting in the dental community because the lower one is the definition of MIH, which is a congenital disease. What about the rest of the 6,000? Is that another disease that we have not yet encountered? Why is that there? And those are the questions. So far, working from a dental perspective, what I see here mostly is I get a lot of questions. So now I just want to get the answers. So this was a simple looking at what is diagnosed. This is going to take a little bit more of explaining. This is our survival graphs. And once again, I'll do the disclaimer. We have decided on, we're going to use this as a starting point, this as an ending point for survival of the tooth. In this case, survival is getting a filling, then it's damaged. So how well did it go? How bad did it go? This is from the discussion in the dental community in Norway. Does it pay off to drill the back milk tooth of a child? And part of them are saying, well, it costs a lot of money. Let's just wait. They're going to fall out anyway. If they hurt, let's pull them. You're not going to keep it until old age. Others are saying, well, they're going to infect the next tooth, which is going to probably be there for the rest of your life, or hopefully be there. So this is a very intense discussion. These data are based on a cohort of 92,000 patients. So the black graph at the top actually are 3 lines. And the way this works in SNOMED, it draws a line, which is the whole line, and then it draws 2 dotted lines, which has the confidence interval. So that means the statistical probability of how sure are you about your data. And you can't tell those lines apart. That's because the p-value or the uncertainty of the data is 0.999999999. It's in R, you should look up the table and it says NA, not applicable. And we were really frustrated because I created this. I looked at the table and it said NA, and I thought, what am I doing wrong? But it was just that the numbers were so big, so it didn't pick up on actually being uncertain. So here we go. If we are able to gather large amounts of data, we are able to draw more safe conclusions when things also are a bit narrow. And then comes the part where we looked at caries. So the red lines, I'm saying, if anyone has said there is a caries on the tooth in front, what does that mean for the survival of the first molar? And you see it drops significantly. So meaning if you have a cavity next to it, the likelihood you're going to get a cavity is much bigger. That doesn't mean it's infecting from one tooth to another. It just means you're bad at brushing your teeth. If you tend to get caries, you get caries. It could be as easy as that. There was also a question, well, do you know that the tooth is there? That's the blue line. We filtered for saying someone has actually looked into the mouth of the patient at one time and seen there is a tooth. So that's why I'm saying the black one is probably not entirely correct. But the blue one, we know that someone has actually stated there is a tooth in front of the tooth we're looking at. It could be a caries on it. It could be a filling. So I haven't filtered saying this is without caries, without fillings. I just said someone looked. That's the blue one. And then the green one is where you filled it. Most likely there has been a caries. So I'm not going to go deeper into explaining your dentistry now. But the point here being, for those who said you don't really need to drill those teeth because they're going to fall out, you will see that there is a significant difference between the red and green areas. Even though we haven't filtered from the red those who actually had their teeth filled, which would probably push it even lower. I'm going to do that when I come back from Norway to see if it has that effect. But you also see one very important thing. 0 here is the year when you're 6 years old, when you're supposed to get that tooth. And for the first 10 years until you're 16, the dotted lines are almost not visible. So I would say the green and red line follows each other in a way that I wouldn't spend a lot of money doing anything about it. But when you hit 20, 26 years, there is a significant difference. So this is based on, we encoded all our data with post coordinations. We stored the post coordinations in Snowstorm X. The tables, the computer here, just thinks it's a string, it's a code. It doesn't care what's in it. So we're using, when we're in R, we're importing the table, we're building vectors using Snowstorm X to filter what we want, and then we let it do the statistical analysis based on that. You can query by ECLs, where the filter is a complete post-coordinated expression. You can base it on subsumptions. You can base it on attribute relationships. You can also, of course, do sequential filters. First filter anatomy, then the clinical event, or first the clinical event and then the anatomy. But what we saw when we used the post-coordination is we really don't need to. We don't need to do those sequential steps, having all kind of data across tables, filtering different columns. Snowstorm does it for us. The terminology and EC and expressions does it in the way we would use several steps to do it. So there's really no reason. The conclusions we draw so far is that data represented by SNOMED CT, combination of pre and post coordinations, can be stored as simple strings in any database and still be analyzed in R using Snowstorm X for filtering data. And I say it's a combination because when you do the query, the response will be both pre and post coordinated data. Graphics can represent clinical concepts in the same manner as a written statement. And these concepts can be represented by SNOMED CT, pre and post coordinations. Post coordinations can represent the complete concept, including the anatomical site and refinement. Which is why I say the only data model you actually need is patient, ID, date, and something. And that something is a SNOMED CT post coordination. Post coordination are properly classified and can be queried. It works. And I think this method would apply equally to data recorded using text entry in the rest of medicine, in addition to dentistry. Thank you.
Thank you. John will now take questions. As a reminder, if you're in the room, please use the mic in the central aisle. Is there any question in the room? Oh, we have one online. Oh, go ahead. Go ahead. Okay.
Thank you for a great presentation. That was very interesting. So at the end, you say that post coordination it's feasible, it can be classified correctly and then queried. We have worked with post coordination in the past and noticed some issues that the unwary author can create things that do not classify as they would have thought. How did you address that problem, or did you encounter that?
Yes, we encountered that. So, of course, we had to be very meticulous on how to create the post coordinations according with the post coordination guide. And when we did that wrong, it simply didn't work. So we bounced all our post coordinations off Snowstorm to get the MRCM validation and get the transformations and everything. And then we made sure to use the code that was returned from Snowstorm. So we didn't try to think of a code. When we had the post coordinated expression created, it was bounced off Snowstorm and we used the response, knowing that then it is classified.
Was that using the close to user syntax?
We both used the close to user syntax, and we have used the more formal context, not the formal expressions. So for like planned procedures, we used the close to user form, but for most of the anatomy inclusions, we used the proper post coordination.
Right. Thanks.
Thank you. Unfortunately, we don't have more time for questions. If you have any, you can meet the presenter in the meetings. With that, we will conclude this session. Thank you, Jørn.